Dear student, this is the last part of this lecture, because in the previous lecture, somehow due to some technical problem, the topics related to error function was misplaced, and the first page was not there, so I had not discussed about the error function. However, this small lecture will consist of error functions, its property, and then the complementary error function, and series expansion on error function, and problems on error function. So actually in this small lecture is done here to discuss about the error functions. So now come to the point, and first go to the error function. So error function, it is denoted by ERFX. The error function is denoted by ERFX, and it is defined mathematically by ERFX, that is equal to 2 by root pi 0 to x e to the power minus u square du. So this is the definition of error function, and it is also called the probability integral. The error function is also called the probability integral, and it is nothing but the incomplete gamma function. So we are not here to discuss about why it is called incomplete gamma function or anything. So just we are here to understand the error function here. So the integral arises in the solution of certain differential equations. For in case to solve different kind of differential equation, we have frequently use, or we have to use employ the error function. If and those cases, in those cases, if we use error function, then the solution of those differential equation becomes easier. And also this kind of error function is also promisingly used in case of theory of probability. So the error function is much more important in case of probability calculations in statistical mechanics. However, here are we to discuss about some properties and properties of this error function, and first come to the point that the error function consists this term here 0 to x e to the minus u square du. This is nothing but the area covered by the curve e to the minus u square in the region u equal to 0 to x, because you know that integration of a function is nothing but the area given by that function in the limit from 0 to, in this case, 0 to x. So now come to the properties. Now from first one is that the most important and one of the important characteristics of error function is ERF minus x is to minus ERFX. That is, in this case, the symmetry property does not does not preserve in this case. So here we have to prove error function of minus x, that is equal to minus of error function of x. Now we know from the definition of error function that error function of x, that is equal to 2 by pi 0 to x e to the power minus u square du. Now from here, if you write or substitute or replace x by minus x, then ERF minus error function of minus x, that will give you 2 by root pi 0 to minus x is there. Yes, because you are replacing x by minus x in this case, and here is e to the power minus u square du. Now from these since we were substituting in this, so we get this form. Now just to compute this integral, you put or you substitute z is equal to minus d1, and then du will give you minus dz, and from this relation here is the limits of integration, that is when u is 0, then that will give you z also 0, and if u is minus x, then z will give you plus x. So error function of minus x is equal to 2 by root pi 0 to x e to the power minus z square will be here, and then minus dz. So that is equal to minus 2 by pi 0 to x e to the power minus z squared dz, and that is nothing but error function of x, because this is the definition of error function of x. So you can easily say that error function of minus x is equal to minus of error function x of x. Here is the second property, another property. It is also important, and it is also frequently used in calculation of probability in statistical mechanics, that is error function 0 of 0 that is equal to 0. To compute this, to prove this, you know already, you have obtained that from this relation. Say, see here, you see here this relation that ERFX, that is ERFX also can be written as minus of ERF, error function of minus x. Here will be minus x. Error function of minus x, that will be equal to minus error function of x, that will be minus error function of x. And now if we write x is equal to 0, then you will get error function of 0, that is equal to minus error function of 0. Then from there, 2 error function of 0 will be 0, error function of 0 will be 0. So from here, error function of 0 is equal to 0 is proved in this case. In this way, you can prove error function of 0 is equal to 0. Now error function of infinity is equal to 1. This is another important characteristics or property of error function. And to do this, you also have to recall the definition of error function of x, that is given here 2 by 2 pi 0 to x e to the minus u squared du. So now just write x as infinity. So error function of infinity is equal to 2 by 2 pi 0 to infinity. Since you are replacing here x by infinity, e to the minus u squared du. And in the similar way, you just replace u squared by z in this case also. So u will be from here z to the power half. So du will be just differentiate this half z to the power minus half dz, and then substitute this value. And here also you have to note the limits of integration, and the limits of integration does not alter in this case, and that can be realized from this relation. So error function of infinity, that is equal to 2 by pi, that is from here, and then 0 to infinity, and e to the minus u square, that is e to the minus z, then half appears from this term du, half z to the minus half dz. And after simplification, that will give you 2 by root pi, and then from here this half comes from this term. So here is half 0 to infinity to the minus z, z to the power, you can write z to the power minus half as z to the half minus 1 dz. So that is equal to, and this is nothing but gamma function of half, because you know that 0 to infinity to the minus z, z to the n minus 1 dz is gamma n. So in this case then is half, so this integral will give you gamma half. So these two terms are here, and gamma half is there, and gamma half is nothing but square root of pi. So this is done here. After calculation, you get error function of infinity is equal to 1. For this reason, the normalization factor in error function is taken as 2 by root pi. Since 2 by root error function of infinity becomes 1. So because of this, this term, that is 2 by root pi, is taken as, in this case here is the 2 by root pi. This time has used as the normalization factor. And here is the plot of error function versus x. The curve is like this, and just you look at this, just see it, nothing to explain or nothing to study in this case, because the error function you have to study the error function qualitatively. So this is just to look at the graph, and the nature of the graph is like this. Now come to the another point, complementary error function. So the complementary error function is another important topic, or another important quantity that is related to the complementary error, that is related to the error function. And the complementary error function which is denoted by error ERF x in this manner, denoted by this, and is defined as ERF x is equal to 2 by pi x to infinity. See here, the limit of integration has changed somewhat here, and it is equal to x to infinity x to infinity e to the minus u square, and this will be du will be here, du will be here, and this is equation number 32. So the relation between error and complementary function is here. See here, the error function and the complementary function has the relation that error function, complementary function of x is equal to 1 minus error function of x. This is the relation between complementary error function and error function of x. That means a complementary error function of x plus error function of x will give you result unity. So to prove this, see here, we know that error function of x is equal to 2 by root pi 2 by root pi 0 to ax e to the power minus u square du, and then ERF cx, error function of complementary function of x, that is equal to 2 by root pi x to infinity e to the power minus u square. Then it will also be du. However, mistakenly it is written as dx. So adding these two terms, ERFX plus ERFCX, that is equal to 2 by root pi 0 to x. First one is 0 to x, 0 to x e to the power minus u square du, plus the second one is 2 by pi x to infinity e to the minus u square du. The correction is done here, but in this case it will be du, and obviously in the definition this will also be du. So we come this, so the addition of these two will give you this, that is equal to 2 by root pi, and you see here the limit is 0 to x and here x to infinity. So if you combine these two, that will give you 0 to infinity e to the minus u square du. And now to compute this value, the value of this integral, and here is that to compute it, let u square is equal to z, then u will be z to the power half, and then du will be half dz, half, then dz, then z to the power minus half. It will not be minus half, it will be only half, plus half, then dz, then z to the power minus half. And here is the limits of integration. The limits of integration will be, when u is 0, then z will also be 0, when u is infinity, then z will also be infinity. So limit of integration here is 0 to infinity, here is 2 by pi, then 0 to infinity, then half is here, this half, this will be plus half. So this half is here, then this z to the minus half is here, and then dz is here, and e to the power minus u square will give you e to the power minus z. So that is equal to 2 by root pi half 0 to infinity e to the minus z to the power minus half dz. That is equal to, that can be written as 2 by root pi half 0 to infinity e to the power minus half, then z to the power half minus 1. This can be written in this fashion, and then dz, and that will give you 2 by root pi, then half, and this is nothing but gamma half, that will give you square root pi. So finally you get 1. So error function of complementary function of x is equal to 1 minus error function of x. So the limit of error function is from 0 to x, and that of the complementary error function is from x to infinity, hence the word complementary, because in this case say that for the complementary function the limit is 0 to x, and for the complementary, for the error function is 0 to x, the limit is 0 to x, and for complementary function it is from x to infinity. So in this sense it is called complementary, the word is complementary used. Now series expansion of error function, we can expand error function in series in series, and here is done, that is done here when x is to be small, and the x should be small, and mod x should be small, and the error function of x can be then expanded with the formula that is given for the series expansion of e to the minus y square. E to the minus y square, you know that will be is equal to 1 minus y square, because you know that e to the power minus x is equal to 1 minus x by 1 factorial, then plus x square by 2 factorial, then x minus x cube by 3 factorial. That is done here, nothing but e to the minus y square is equal to 1 minus y square by 1 factorial, then y4 by 2 factorial, then minus y6 by 3 factorial, and so on. And you know that the error function is can be written in this manner also, in this form also. Error function of x is equal to 2 by root pi 0 to x e to the minus y square dy. You can write also in this manner. So then just write it 2 by root pi 0 to x and this series. Just expand it to the minus y square. So the series is written here, then dy. So 2 by root pi and multiply, just integrate this all these things. So this will give you y and this will give you y cube by 3 and this 1 factorial here, and this will give you y to the 5 by 5 and 2 factorials here, and minus then y to the 7 by 7 into 3 factorial and so on 0 to x. After using the limits, you can find ERFX is equal to 2 by root pi x minus x cubed by 3, then x5 by 5 into 2 factorial, then x to the 7, x to the 7 by 3 into 7, 7 into 3 factorial and so on. So this is the series expansion of the error function. Now here is a problem. We have to prove that a to b to the minus x squared dx is equal to root pi by 2 erf b minus erf a. So here we have to prove this problem. Now we know that from the error function, definition of the error function, that erfx is equal to 2 by root pi 0 to x e to the power minus u square du. And from this relation you can write error function of b is equal to 2 by root pi 0 to b e to the minus u square du. And also you can write error function of a is equal to 2 by root pi 0 to a e to the power minus u square du. So from after subtracting these second one from the first one, so erf b minus erf a is equal to 2 by root pi 0 to b e to the minus u square du minus 2 by root pi 0 to a e to the power minus u square du. And that is equal to 2 by root pi 0 to b to the minus u square du, and you can write this as with a minus sign a to 0. So that is written here plus 2 by root pi a to 0 e to the minus u square du. And from here if you combine these two, then you will get 2 by root pi a to b 0, because it is 0 to b and it is a to 0. So it is from a to b e to the power minus u square du. And now to compute the value of this term. And now if you in generally write for the generalization, if you write it at in general, then you will get erf b minus erf a, that is 2 by root pi a to b e to the minus x square dx. Just for the generalization you use x as u. So for this is the generalization form of this term. So erf b minus erf a is 2 by root pi 0 to b e to the minus x square dx. So from this relation, you can write that erf b minus erf a, that is 2 by root pi a to b e to the minus x square dx, that is equal to this. So you can easily prove from here that 2 by root pi a to b e to the minus x square dx is equal to erf b minus erf a. Apart from here, that 0 to b to the power minus x square dx is equal to root pi by 2 a to b to the minus x square dx. So this is the end of this lecture, and just look at all these things and make all the corrections that I have mentioned, and hope you will understand all these things.